In this lecture, we are going to discuss these two questions. So let's start with question number 1. Many manufacturers have quality control programs that include inspection of incoming materials for defects. Suppose a computer manufacturer receives computer boards in lots of 5. 2 boards are selected from each lot for inspection. We can represent possible outcomes of the selection process by pairs. For example, the pair 1-2 represents the selection of boards 1 and 2 for inspection. So in part A, we have to list down the 10 different possible outcomes. So let us first confirm that yes, there are 10 possible outcomes in this case. So because in this case the ordering does not matter, so we can use combination instead of permutation. So we can write in this case number of possible outcomes is equal to 5C2. This is because in this case the ordering does not matter. So the pair 1-2 is equal to the pair 2-1. So this means that the number of possible outcomes is equal to 5 factorial divided by 2 factorial and 5 minus 2 factorial. So this is equal to 5 factorial divided by 2 factorial and multiplied by 3 factorial. And this is equal to 5 into 4 into 3 factorial divided by 2 multiplied by 1 into 3 factorial. We can cancel these two and this is equal to 10. So the number of possible outcomes that we have in this case is equal to 10, and we have used combination to find it because the ordering does not matter in this case. Now let's list down all these different possible outcomes. So the first outcome could be 1, 2. Second outcome could be 1, 3. Third outcome 1, 4. And fourth outcome 1, 5. Note that the pair 1, 2 represents the selection of boards 1 and 2 for inspection. So 1, 3 represents the selection of boards 1 and 3 for inspection, and so on. Similarly, we can have 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, and 4, 5. So these are the 10 different possible outcomes. Now let's move to part B. Suppose that boards 1 and 2 are the only defective boards in a lot of 5. 2 boards are to be chosen at random. Define X to be the number of defective boards observed among those inspected. Find the probability distribution of X. So this is part B, and here we have to find the probability distribution of X. As X is the number of defective boards observed among those inspected, and we are given that there are only 2 boards that are defective, so that means the maximum value that X can take is equal to 2. So the possible values of X are 0, 1 and 2. X equal to 0 means that there is no defective board among those inspected. X is equal to 1 means that there is only one defective board among those inspected, and X is equal to 2 means both the boards are defective. So now we have to find these probability values to complete this probability distribution. So what is the probability that X is equal to 0? So what is the probability that X is equal to 0? So this means that none of the boards should be defective, and it's given to us in the question that boards 1 and 2 are the only defective boards. So the outcomes that we should write here are 3 and 4, 3, 5 and 4, 5. Because in these outcomes there is no defective board. So the probability that X is equal to 0 is equal to 1 by 10 plus 1 by 10 plus 1 by 10 and this is equal to 3 by 10. It's 1 by 10 because we have 10 possible outcomes and all the outcomes are equally likely. Okay, so the probability that x is equal to 0 is 3 by 10, or you can say it's 0.3. Let's now find the probability that x is equal to 1. So the probability that x is equal to 1. This means only one board should be defective. So this means that apart from this outcome, because in this outcome we have both the boards that are defective, and apart from these three outcomes in which no boards are defective, all the other outcomes, that is all these 6 outcomes, have one defective board. So the probability that x is equal to 1 is equal to the probability that we get outcome 1 by 3, 1 by 4, 1 by 5, or 2 by 3, or 2 by 4, or 2 by 5. So these are the 6 outcomes. So in this case, the probability that x is equal to 1 is equal to 6 divided by 10, and this is equal to 0.6. This is equal to 0.3. So we can write 0.6 here. Now the last probability is the probability that x is equal to 2. So the probability that x is equal to 2, this will happen when both the boards are defective. So the only possible outcome corresponding to x is equal to 2 is 1, 2. So in this case, both the boards are defective, and the probability of getting this outcome is equal to 1 by 10. That is 0.10. So we can write 0.1 here. So this is the probability distribution of x. Now let's move to part C. Let fx denote the cumulative distribution function of x. First determine f0 is equal to probability that x is less than equal to 0, f1 and f2. Then obtain fx for all other x. So in this case, we have to calculate the cumulative probabilities. So let me first write down the probability distribution of x. So it's x here and the probability values of x 0, 1, 2, 0.3, 0.6 and 0.1. So this is the probability distribution of x. So we have to first calculate f of 0, which is equal to the probability that x is less than equal to 0. So we have to calculate f of 0, which is equal to probability that x is less than equal to 0. And this is equal to the probability that x is equal to 0, because the minimum value that x takes is 0. And this is equal to 0.3 from this table. Now we have to calculate the f of 1. f1. So this is equal to probability that x is less than equal to 1, because this is the cumulative distribution function. So this is equal to probability that x is equal to 0 plus probability that x is equal to 1. And this is equal to 0.3 plus 0.6. So this is equal to 0.9. And now we have to calculate f of 2. So this is equal to probability that x is less than equal to 2. So it is equal to probability that x is equal to 0 plus probability that x is equal to 1 plus probability that x is equal to 2. So this is equal to 0.3 plus 0.6 plus 0.1 equal to 1. And then obtain fx for all other x. So let me write the complete cumulative distribution function now. So we can write fx is equal to 0 when x is less than 0, because x does not take values less than 0. It is 0.3 for values of x between 0 and 1. Right, we have an equal to sign here and I'm not putting an equal to sign here. So this means that this is the probability that x is equal to 0. fx is equal to 0.9 when x is between 1 and 2, right? Because f of 1 is equal to 0.9. So that's why I've put an equal to sign here and not here. And fx is equal to 1 when x is greater than equal to 2. Because the value of f of 2 is equal to 1, and if you calculate the value of f of 3, it will also be equal to 1, and same goes for f of 4, f of 5, f of 6. So we can summarize everything and write in this table in this manner. And note that as asked in the question, this covers all the other x values. So we have incorporated x less than 0 as well and x greater than equal to 2 as well. So this is the complete cumulative distribution function. Now let's move to question number 2. Some parts of California are particularly earthquake prone. Suppose that in one metropolitan area, 25% of all homeowners are insured against earthquake damage. 4 homeowners are to be selected at random. Let X denote the number among the 4 who have earthquake insurance. In part A, we have to find the probability distribution of X. So let's start with part A. We are given that X denote the number among the 4 who have earthquake insurance. So the possible values that X can take is 0, 1, 2, 3 and 4. And to complete the probability distribution of X, we have to find these probabilities. So let's list down the sample space of this question. So let's list down all the possible outcomes that we can have. To list down all the possible outcomes, let's write some notations first. So let's say that S denotes a homeowner who has insurance. So homeowner who has insurance. And let F denote a homeowner who does not have insurance. So does not have insurance. Okay, so these are the notations that we are going to use. Let's now write the sample space. So we are selecting 4 homeowners at random. So it could be the case that all of them have insurance. So S. This denotes that the first person has insurance, the second has insurance, the third and the fourth as well. Or it could be the case that first 3 have insurance and the fourth one does not. Or say first 2 have insurance, the third one does not have insurance, and then the fourth one has insurance. And similarly, we can write all the possible outcomes that we could have. So next outcome could be SFSS. Next could be FSSS. So these are the possible outcomes. Here are 16 possible outcomes. Now we have to find all these probabilities to complete this probability distribution table. So let's first find the probability that X is equal to 0. As X denote the number among the 4 who have earthquake insurance, the value of X will be equal to 0 when the outcome is FFFF. So that means the corresponding outcome is FFFF. And we know that these are independent because our sample is random. So that means we can write it is equal to probability of F multiplied by probability of F multiplied by probability of F and multiplied by the probability of F. So this is the probability that the first one does not have insurance. This is the probability that the second person selected does not have insurance, and similarly. We are given in the question that 25% are insured against earthquake damage. So this means that probability of S is equal to 0.25. So this means that probability of F is equal to 1 minus 0.25. So it is equal to 0.75. So in this case, the probability that X is equal to 0 is equal to 0.75 raised to the power 4, and this is equal to 0.3164. So this probability is equal to 0.3164. Let's now find the probability that x is equal to 1. So probability that x is equal to 1. So the corresponding outcomes are, for x to be equal to 1, we need only one person to have insurance in our sample of 4 persons. So that means the outcome should have only one S. So let's see how many outcomes are there. So one is this outcome, one is this outcome, one is this outcome, and one is this outcome. And I guess that's it. We have 4 outcomes with only one S. This means we can write all those outcomes here. So this is equal to the probability of F, 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 S, F, F, S, F, F, S, F, F, and S, F, F, F. So these are the corresponding outcomes. So we know that the probability of getting an S is 0.25 and the probability of F is 0.75, and these are independent. So we can write this is equal to 0.75 raised to the power 3 multiplied by 0.25 plus 0.75 raised to the power 3 multiplied by 0.25, as we have 3f and 1s, and for these two also we'll get the same expression. So 0.75 raised to the power 3 multiplied by 0.25, this is for this, and the last one 0.75 raised to the power 3 multiplied by 0.25. So this is equal to 0.4219. So this probability is equal to 0.4219. Let's now find the probability that x is equal to 2. So probability that x is equal to 2. So let's see what all outcomes correspond to this. So to have x is equal to 2, we should have 2s in the outcomes. So let me choose a different color now. Okay, so we should have 2s. In this outcome we have 2s, so this is outcome 1. In this outcome we have 2s. In this outcome we have 2s. In this, and in this. So there are total 6 outcomes with 2s. Okay, so we can write all these outcomes here, and the outcomes are S, S, F, F, S, F, S, F, S, F, 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 and you can write the other 3 outcomes as well. Now let's find the probability. So the probability of this outcome is 0.25 square multiplied by 0.75 square, and the probability of this outcome is also equal to 0.25 square multiplied by 0.75 square. In fact, the probability of all these 6 outcomes is same. It's 0.25 square multiplied by 0.75 square. So I'm not writing the whole expression. So what we get is 6 multiplied by 0.25 square multiplied by 0.75 square, and this is equal to 0.2109. So this is equal to 0.2109. Just like I have found the probability for these 3 values of x, we can also find the probability for these 2 values of x. So to find the probability that x is equal to 3, we have to highlight the outcomes where we have 3s. So in that case, we will have 4 outcomes. One is this, one is this, this, and this. So we can use these outcomes to find the probability of x when x is equal to 3. Similarly, we can find the probability that x is equal to 4. So x is equal to 4 means that we should have all s. So x is equal to 4 corresponds to this outcome, and then we can find the probability of this outcome. So after solving for this, the probability values that you will get here are 0.0469. So here you will get 0.0469, and 0.0039. So I'm not showing you the calculation of these two probabilities. I hope it's all clear now so you can calculate it on your own. So these are the values that you will get. So with this, we are done with the part A of this question. So in part A, we had to find the probability distribution of X. So this is the probability distribution of X. You can try and sum all these values and the sum will be equal to 1. Now let's move to part B. In part B, we have to write what is the most likely value for X. Well, the probability that X is equal to 1 is 0.4219 and it is greater than all the other probabilities listed in this table. So the most likely value for X is equal to 1. So this is equal to 1. So now let's move to part C. So in part C, we have to calculate the probability that at least 2 of the 4 selected have earthquake insurance. So that means we have to calculate the probability that X is greater than equal to 2. So we can calculate this probability by adding the probability that X is equal to 2 plus the probability that X is equal to 3 plus the probability that X is equal to 4. So this is equal to 0.2109 plus 0.0469 plus 0.0039 and this is equal to 0.2617. So the probability that at least 2 of the 4 selected have earthquake insurance is 0.2617.